One of the most exciting is CUDA-Q. CUDA-X is this suite of libraries, a library suite for accelerating applications and algorithms on top of CUDA. We now have CUDA-Q. CUDA-Q is for quantum computing, for classical quantum classical computing based on GPUs. We've been working on CUDA-Q now for several years, and today I can tell you there's an inflection point happening in quantum computing. As you know, the first physical qubit was demonstrated some nearly 30 years ago. An error correction algorithm was invented in 1995. And in 2023, almost 30 years later, the world's first logical qubit was demonstrated by Google. Now, since then, a couple of years later, the number of logical qubits, which is represented by a whole lot of physical qubits with error correction, the number of logical qubits are starting to grow. Well, just like Moore's Law would, I could totally expect 10 times more logical qubits every 5 years, 100 times more logical qubits every 10 years. Those logical qubits would become better error corrected, more robust, higher performance, more resilient, and of course, will continue to be scalable. Quantum computing is reaching an inflection point. We've been working with quantum computing companies all over the world in several different ways, but here in Europe, there's a large community. I saw Pascal last night. I saw Barcelona supercomputing last night. It is clear now we're within reach of being able to apply quantum computing, quantum classical computing, in areas that can solve some interesting problems in the coming years. This is a really exciting time. And so we've been working with all of the supercomputing centers. It's very clear now that over the next several years, or at least the next generation of supercomputers, every single one of them will have a QPU assigned and QPU connected to GPUs. The QPU will do quantum computing, of course, and the GPUs would be used for pre-processing, for control, for error correction, which will be intensely computationally intensive, post-processing and such. Between the two architectures, just as we accelerated the CPU, now there's QPU working with the GPU to enable the next generation of computing. Well, today we're announcing that our entire quantum algorithm stack is now accelerated on Grace Blackwell 200, and the speed up is utterly incredible. We work with the quantum computing industry in several different ways. One way is using cuQuantum to simulate the qubits or simulate the algorithms that runs on top of these quantum computers, essentially using a classical computer to simulate or emulate a quantum computer. At the other extreme, extremely important is CUDA-Q, basically inventing a new CUDA that extends CUDA into quantum classical, so that applications that are developed on CUDA-Q can run before the quantum computer arrives in an emulated way, or after the quantum computer arrives in a collaborative way, a quantum classical accelerated computing approach. And so today we're announcing CUDA-Q is available for Grace Blackwell. The ecosystem here is incredibly rich. And of course, Europe is deep with science and deep with supercomputing expertise and deep with heritage in this area, and it's not surprising to see quantum computing advance here. In the next several years, we're going to see a really fantastic inflection point. So anyways, for all of the quantum computer industry that have been working on this for 3 decades now, I congratulate you for just the incredible accomplishment and the milestones today. Thank you.